The National Electrical Code, NEC, generally requires that each building has a single service. This requirement is outlined in NEC Article 230.2. The purpose of this rule is to ensure that each building has its own dedicated power source and electrical system. Running a 480 volts feeder from another building to supply loads in a different building is generally not permitted due to several reasons. Firstly, safety concerns arise from the potential inability to isolate power to each building independently in the event of an emergency such as a fire or power outage. Secondly, many building codes mandate that each building has its own dedicated service to ensure that the electrical system is designed and installed to meet the specific needs and safety requirements of that building. Thirdly, the NEC requires that each building has a single service unless specifically permitted otherwise. Exceptions to the one service per building rule exist, but these are typically limited to specific situations. Firstly, small accessory buildings that are not connected to the main building might be an exception. Secondly, temporary power installations can be an exception. Thirdly, buildings that are part of a larger complex and have a common electrical system might qualify for an exception. However, given the scenario of a hospital with interconnected buildings separated by fire and smoke walls, the general rule of one service per building typically applies. The best solution is to install an additional generator or increase the capacity of the existing generator in the building with the overloaded emergency generator. This will ensure that the building has its own dedicated power source and meets all applicable safety and code requirements. To elaborate further on the NEC requirements, Article 230 covers services. A service is defined as the conductors and equipment for delivering electric power from the serving utility to the wiring system of the premises served. Section 230.2. A, as mentioned before, states that a building or other structure served shall be supplied by only one service. The intent is to have a single point of disconnect for the entire building, allowing emergency responders or maintenance personnel to easily de-energize the electrical system in case of fire, electrical hazard, or other emergency. There are exceptions to this rule, as outlined in 230.2. One such exception involves special conditions. Additional services are permitted under special conditions that make it impractical to supply power to an entire building from a single source. Examples of special conditions include buildings of large area, capacity requirements, or for reasons of effective area. If a building is so large that the calculated load exceeds the capacity of a single service, multiple services may be permitted. If the capacity requirements exceed what a single service can reasonably handle, multiple services are allowed. For reasons of effective area, if a building is divided into multiple occupancies, each occupancy may have its own service. The exception might apply if the hospital building is very large and has multiple distinct wings or sections separated by firewalls, and each section has significant electrical loads. Another exception involves multiple occupancy buildings. For a multiple occupancy building, each occupant shall have access to adequate electric power. A building qualifies as a multiple occupancy building when it has multiple tenants or occupants, each requiring their own electrical service. In this case, each occupancy may be served by its own service. This exception might apply if the hospital building includes leased spaces, such as doctors' offices or clinics that are not directly part of the hospital's main operations. Another exception is capacity requirements. Additional services shall be permitted where the capacity requirements are in excess of 2000 amps at a supply voltage of 600 volts or less. This exception applies when the total electrical demand of the building exceeds the capacity of a single service. If the hospital's electrical load is extremely high, requiring more than 2000 amps at 600 volts or less, multiple services may be permitted. A final exception involves different characteristics. Additional services shall be permitted for different voltages, frequencies, or phases, or for different uses, such as control of outside lighting from a multiple occupancy building. This exception applies when different parts of the building require different electrical characteristics. If the hospital has specialized equipment that requires different voltages or frequencies than the main electrical system, multiple services may be permitted. For safety concerns, in the event of a fire, electrical fault, or other emergency, it is crucial to be able to quickly and safely energize the electrical system. With multiple buildings interconnected by a 480 volts feeder, it becomes difficult to isolate the power to each building independently. This could delay emergency response efforts and increase the risk of injury or property damage. Building codes often require that each building has its own dedicated service to ensure that the electrical system is designed and installed in a manner that meets the specific needs and safety requirements of the building. This includes proper grounding, overcurrent protection, and compliance with all applicable electrical codes and standards. Ignoring these codes could result in safety hazards and legal liabilities. Given the hospital's existing configuration with multiple services and generators, it is important to carefully evaluate the electrical system and determine the best approach for addressing the overloaded emergency generator. A comprehensive electrical study should be conducted to assess the load's capacity and safety of the existing system. It is essential to ensure that any modifications or additions to the electrical system comply with all applicable codes and standards. As mentioned, one solution is to install an additional generator. Installing an additional generator specifically for the building with the overloaded emergency generator is a viable option. This would provide a dedicated power source for the building and ensure that it has sufficient emergency power capacity. Another solution is to upgrade the existing generator. Upgrading the capacity of the existing generator in the building is another option. This would provide more emergency power capacity for the building and eliminate the need to run a feeder from another building. The NEC also has requirements for emergency systems. Article 700 covers emergency systems. These are electrical systems intended to supply power automatically to designated areas and equipment in the event of failure of the normal power supply. Emergency systems are typically installed in buildings where life safety is critical, such as hospitals, fire stations, and high-rise buildings. Section 700.12 covers the sources of power for emergency systems. Emergency systems must have a reliable source of power that is capable of providing power within the time required for the application. Acceptable sources of power include generators, storage batteries, and uninterruptible power supplies, UPS. Section 700.12. B covers generator sets. Generator sets must be sized to supply all essential loads and must have adequate capacity to handle the inrush current of motors and other equipment. The generator must be located in a separate room or enclosure that is protected from fire and other hazards. The generator must be tested regularly to ensure that it is operating properly. The NEC also covers essential electrical systems for healthcare facilities. Article 517 applies to electrical installations in healthcare facilities. These are facilities that provide medical, surgical, or other healthcare services to patients. Section 517.30 covers essential electrical systems. Healthcare facilities must have an essential electrical system that is capable of providing power to critical areas and equipment in the event of a power outage. The essential electrical system must consist of two or more independent sources of power, such as a normal source and an alternate source. The normal source is typically the utility power supply, while the alternate source is typically a generator or a UPS. Section 517.30. C covers the essential electrical system loads. The essential electrical system loads must be divided into two categories: life safety branch and critical branch. The life safety branch includes loads that are essential for the safety of patients and staff, such as lighting, fire alarm systems, and communication systems. The critical branch includes loads that are essential for patient care, such as medical equipment, operating rooms, and intensive care units. The NEC also covers transfer switches. Article 700 covers transfer switches for emergency systems. A transfer switch is a device that automatically transfers the electrical load from the normal source of power to the alternate source of power in the event of a power outage. Transfer switches are essential components of emergency and standby power systems, ensuring a seamless transition to backup power when the normal power supply fails. Section 700.5 covers the types of transfer switches. Transfer switches must be automatic and must be listed for emergency use. Automatic transfer switches (ATS) automatically transfer the load from the normal source to the alternate source upon loss of normal power and retransfer the load back to the normal source when power is restored. Section 700.6 covers the installation of transfer switches. Transfer switches must be installed in a location that is accessible and protected from damage. The transfer switch must be properly grounded and must be connected to the emergency power system in accordance with the NEC. In summary, running a 480 volts feeder from another building is generally not permitted due to safety concerns, building code requirements, and NEC regulations. Instead, consider installing an additional generator or upgrading the existing generator to provide dedicated power to the building with the overloaded emergency generator. Ensure that all electrical work complies with applicable codes and standards to maintain a safe and reliable electrical system. It is crucial to consult with a qualified electrical engineer to determine the best solution for the specific needs of the hospital and to ensure compliance with all applicable codes and regulations. This approach will help to maintain a safe and reliable electrical system for the hospital, ensuring the safety of patients and staff. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It is important for electrical professionals to stay up to date on the latest version of the NEC to ensure that their work is safe and compliant. Furthermore, local amendments to the NEC may exist, so it is important to consult local authorities having jurisdiction to ensure compliance with all applicable regulations. The AHJ is the entity responsible for enforcing the NEC and other electrical codes in a particular area. It may have additional requirements or interpretations that must be followed. The NEC provides detailed guidelines for the installation of electrical systems in buildings, including wiring methods, overcurrent protection, grounding, and bonding. Proper grounding and bonding are essential for safety, as they help to prevent electrical shock and fire hazards. The NEC specifies the types of wiring methods that are permitted for different applications, such as conduit, cable, and raceways. It also specifies the requirements for the size and type of conductors that must be used. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the requirements for the selection and installation of overcurrent protection devices. The NEC also addresses the installation of electrical equipment in hazardous locations, such as areas where flammable gases or vapors are present. Special precautions must be taken to prevent explosions and fires in these locations. In addition to the NEC, other standards and regulations may apply to electrical installations, such as those issued by the Occupational Safety and Health Administration (OSHA) and the National Fire Protection Association (NFPA). OSHA sets standards for workplace safety, including electrical safety. NFPA publishes codes and standards related to fire prevention and electrical safety. Electrical safety is a critical concern in all types of buildings, including hospitals. Electrical hazards can cause serious injuries or even death. It is important to follow all applicable codes and standards to ensure the safety of electrical installations. Regular inspections and maintenance of electrical systems are essential for identifying and correcting potential hazards. Qualified electrical professionals should perform all electrical work. They have the knowledge and experience to ensure that electrical installations are safe and compliant.